Hello dear students, today we are going to see chapter 3, the world of numbers, where we are going to solve the exercise set 3.1 and 3.2. Let's see question number 1. A merchant in the port city of Lothal is exchanging bag of spices for copper ingots. He receives 15 ingots for every 2 bags of spices. If he brings 12 bags of spices to the market, how many copper ingots will he leave with? Now here, if you see children, I'll be teaching you 2 methods to solve, so you can opt any one method to solve these type of questions. Let's see method number 1 using proportion. Now what is given here? 2 bags and 15 ingots. That means he receives 15 ingots for every 2 bags of spices. Now next is, if he brings 12 bags of spices to the market, how many copper ingots will he leave with? So for 12 bags, we are not aware of the copper ingots, so we term it as X. We can take it as X ingots. Now let us set up the proportion here. So 2 is to 15, which is equal to 12 is to X. That is 2 upon 15 is equal to 12 upon X. So how you are going to solve this? You need to cross multiply. 2 into X is equal to 12 into 15, and 2X will be 12 into 15 is 180, and you will find the value of X by dividing 180 by 2. So you get X as 90. So what is X here? That is the number of copper ingots which he leave with. Let's see method number 2. Now here you can do the scaling the ratio method. Now from 2 bags, what is mentioned? 15 ingots. So to get 12 bags, what you are going to do is you need to multiply 2 by 6, or you can say even 12 is divided by 2, you get 6. So 2 into 6 is equal to 12. Now you multiply the number of ingots by the same factor. That is 15 into 6, which is 90. So 12 bags will be what? 19 ingots, and that's your final answer. So the merchant will leave the market with 90 copper ingots. Let's see question number 2. Look at the sequence of numbers on one column of the Shango bone. That's 11, 13, 17, and 19. So what do these numbers have in common? List the next 3 numbers that fit this pattern. Now children, I just wanted to give you a small description about the Shango bone. It is one of the oldest known mathematical artifacts in the world. It is a small bone tool which is believed to be from a baboon with a series of notches carved into it. Now, what is the given sequence, as we need to understand the question and follow step by step? It's 11, 13, 17, and 19. So observation is that all these numbers are what? They are the prime numbers. A prime number is what? I think you all are aware of. It is exactly 2 factors, which is 1 and the number itself. So what will be the next prime number which is given here after prime numbers after 19? It will be 23, 29, 31. So common property here, if you understand, that is they are prime numbers. Now this type of questions are pretty easy one, but you need to read the question before solving it properly. Let's see question number 3. So we know that natural numbers are closed under addition. The sum of any 2 natural numbers is always a natural number. So are they closed under subtraction? So you need to provide some examples to justify your answer. Now when we talk about the natural numbers, we know it is 1, 2, 3, 4, 5. For example, 1, 8 minus 5 is 3. But what exactly closed under subtraction means? It is a set is said to be closed under subtraction if subtracting any 2 numbers from the set always gives a number that is also in the set. So if we take 8 minus 5, we get 3. So 3 is a natural number. Now if you take 5 minus 8, it is minus 3. It is not a natural number. So 4 minus 4 is 0. 0 is not considered a natural number in many definitions, if you understand. So basically natural numbers are not closed under subtraction. That is, this is because subtracting 2 natural numbers can sometimes result in 0. Again, that which is not considered a natural number, or it is a negative number, which is definitely not a natural number. So you can give your answer by giving different examples, by certain examples by justifying your answer. Question number 4. Ancient Indians, they used the joints of their fingers to count, a practice still seen today. So each finger has 3 joints and the thumb is used to count them. So how many can you count on one hand, and how does this relate to the ancient base 12 counting systems? Now, if you see what is given here, each finger has 3 joints. Now the thumb is used to count the joint. So excluding the thumb, there are 4 fingers. So step 1, if you count total joint, you will get 4 fingers into 3 joints each. So that becomes 12. That is on one hand. Now what about the base? That is, why was base 12 useful? The number 12 is very convenient because it can be divided evenly by 1, 2, 3, 4, 6 or 12. So now this makes the calculations involving fractions easier than with many other numbers. For example, 12 divided by 2, 12 divided by 3, 12 divided by 4. So likewise, examples of base 12 around us today, if you want to figure it out, so you will find even today traces of the ancient base 12 system remain same. That is 12 months on a year, 12 hours on a clock face, 12 inches in a foot, or even 1 dozen is equal to 12 items. So I believe that these type of questions which is related to the real life applications, or questions which is related to the ancient techniques, that is pretty clear. Next is our exercise 3.2. Let's understand these questions. The temperature in the high altitude desert of Ladakh is recorded as 4 degrees Celsius at noon. By midnight, it drops by 15 degrees Celsius. So what is the midnight temperature? Now what is given here, children? Temperature at noon is 4 degrees Celsius. Drop in temperature recorded is 15 degrees Celsius. Now what is the midnight temperature? So in this, 4 minus 15 will be the answer, that is minus 11. So how are you going to calculate 4 minus 15, which is equal to minus 11, and that is the midnight temperature. Question number 2. A spice trader takes a loan or a debt of rupees 850. The next day he makes a profit of rupees 1200. The following week he incurs a loss of rupees 450. Write the sequence as an equation using integers and calculate his final financial standing. Now let's understand the situation. Now what is the debt here? Debt of rupees 850. That is the negative integer, which is minus 850. And the profit is 1200. So the positive integer is plus 1200. Like when we try to do the questions on profit and loss. So loss is negative and the profit we always calculate as positive. So here the loss of 450, that is the negative integer again, it is minus 450, sorry. Now how are you going to form the equation? So it is minus 850 plus 1200 minus 450. And what will be the next step? And you will calculate this entire equation. You will get answer as minus 100. So final financial standing is 100, debt, that is loss. Question number 3. You need to calculate the following using Brahmagupta's law. Now here minus 12 into 5. Let's see question number 1. So what is the rule, children? These are the basic rules, which is negative into positive will give you negative. So calculation is 12 into 5 is 60. So therefore minus 12 into 5 will be minus 60. Next question number 2. Minus 8 into minus 7. So what is the rule here? Negative into negative is positive. So likewise, you just have to calculate, like minus into minus is plus. So that will give you 56. Question number 3. Now here it's 0, minus, and in bracket you have minus 14. So subtracting a negative number is the same as adding its positive value. So minus into minus is plus. So 0 plus 14 is 14. Minus 20 divided by 4. These are the simple division sums, kids. So when you are going to divide it, you will get answer minus 5. Now you need to do question number 4. Explain using a real world example of debt why subtracting a negative number is the same as adding a positive number. Suppose, let's take one example. You have rupees 10 in your pocket. You also have a debt of rupees 5. So debt can be represented as minus 5. So now imagine a friend pays off or removes your debt at rupees 5. So mathematically 10 minus 5. That means removing a debt means removing a negative account. So 10 plus 5 will give you 15. So likewise, not only this, you can even try different examples, a real world example of debt.